Hello, everyone, and welcome to this month's Department of Energy Python Exchange. My name is Cameron Riddell, and I will be your host this evening, afternoon, or morning, right, depending on the time zone that you live in. As you all may know, our goal is to have Python thrive within the National Lab System and associated research sites. In support of that goal, we are joined today by our guest panelist, Leah Wasser, who is a remote sensing ecologist turned data scientist who nowadays spends most of her time operating pyOpenSci, which is a diverse global community that supports open source Python tools that drive open science through, again, open peer review, training, and membership. But before we get into the agenda for today, I did want to just run a few key points by you. As you all may know, this call will be recorded, edited, and posted online. So do bear in mind that we want you to be conscious of the information and the questions that you may ask to ensure that you are not accidentally sharing anything that is privileged or requires clearance. Additionally, as you all may know, we are a growing community, and we would like to stay in touch with each of you. If you would like to be kept up to date with our monthly exchanges, please sign up for our mailing list, which you can find on the website meetup.doepy.org. You can additionally find the recordings of all past exchanges on this site, as well as a recording of today's exchange once it has been edited. For those of you who have never joined us for an exchange before, I would like to share with you that these exchanges are typically broken down into 4 parts. First, we'll introduce our fantastic lineup of host and guest panelists so that you may all get to know them, as well as their respective fields and backgrounds. Then, we'll kick off into a coding activity where we'll ask some very applied questions to our panelists to elicit some practical discussion about best practices in software development and where they fit into the world of academic or scientific research, and just have some fun with the general topic of Python. Third, we'll turn things over to our guest panelist, Leah, who will share some prepared remarks on Python and pyOpenSci, and where pyOpenSci can fit into your life as a researcher, whether you are a researcher or a software developer or a research support, right, engineer or staff. Finally, to wrap up, we will have a full discussion about the points made by our guest panelists. And for everyone joining us in the audience, this is your chance to ask questions and engage with our panel to help us all understand where Python fits into the life of a researcher. So, with that all being said, I would love to go ahead and introduce our host and guest panelists for today. And in order to do that, I will, of course, share my screen with you. So behind me, you'll see my screen. I'll hide here in the corner, and I'll even go ahead and just double share my screen so you can see the text on my screen just as clearly as I do. The Python Exchange. This is our website. If you have not jotted down that link, you can find recordings of all of our past sessions and information on our upcoming sessions here at meetup.doepy.org. Let's first talk to our host panelists. Well, I guess I am up first, as per usual. Hello, everyone. My name is Cameron Riddell, and I'm not affiliated with a specific lab here at the DOE, but I do have a background in academic research as I studied cognitive science in graduate school. For today's exchange, I would love to discuss any and all questions related to Python as a whole, or specific concepts and uses in Python's vast scientific computing ecosystem relating to tools like NumPy, Pandas, Matplotlib. Next up, we are also joined today by James Powell. James, I see that you're affiliated with NumFocus. Can you tell us a little bit about that and a little bit about the questions you would love to field for us today?
Hi, everybody. My name is James Powell. I serve as chairman of the NumFocus Board of Directors, where NumFocus is the 501c3 nonprofit that fiscally sponsors major tools in scientific computing in Python. I also happen to have the pleasure of working together with Cameron. Cameron didn't mention this, but he is the PI on a 3-year NASA grant whose goal is to bring open source and scientific computing approaches to 25,000 scientists within the NASA Science Mission Directorate. And so despite his lack of affiliation with the National Lab, we definitely do a lot of work with the US federal government, with groups like NASA, JPL, and the National Labs themselves. And so please do ask us anything that you might be curious about with regards to how do I develop better computational skills among scientific computing staff in these sorts of research roles.
Fantastic. Thank you for that, James. Next up, I would love to hear from our host panelist, Dan Allen. Dan, I see you're affiliated with BNL. Can you tell us a little bit about what is it that you do, and what questions would you love to field for us today?
Sure. At Brookhaven, I work in a scientific software support role, designing software to enable new scientific capabilities and helping scientists use the tools developed both at BNL and in the larger scientific Python community. I also work a lot with our peer facilities within the DOE and internationally to share tools and ideas. And I'm happy to answer questions about building those kinds of informal, loose, ground-up communities across scientific facilities.
Fantastic. Well, Dan, I think you'll have a lot of questions for Leah, because building these Python communities turns out to be such a core piece of really driving scientific research, because we have these communities, these tight-knit communities where you can really rely on questions and answers and finding someone who has already done all of the coding or all of the legwork in terms of what you want to do with your research, thus making it easy for you to apply a given tool to your project. So I'm very excited for today's discussion. Next up, Dan, we are joined by Dan's colleague, Tom Caswell. And Tom, I see that you're also affiliated with the Brookhaven National Lab. Can you tell us a little bit about what you do and what types of questions you would want to field for us today?
So as Cameron said, I'm Tom Caswell. I work in the data acquisition sectors group at SLS2, where we work on building high-level control systems for data acquisition at experimental facilities. In addition to my role at Brookhaven, I'm also the project lead for Matplotlib, and I'm happy to take questions about any aspect of visualization in Python, data acquisition, or how to manage a large distributed community of developers.
Fantastic. So Tom, you're very experienced in the larger Python community, so we'll definitely have a lot of questions for you today. Thank you very much for joining us. We are also potentially joined by a past panelist, Jim Povarsky. And Jim, if you are joining us today, I would love to hear just a few words from you about what is it that you do with the IRIS HEP program and what types of questions you would love to answer for us today.
Hi, yes, I'm Jim Povarsky. I work for Princeton University. IRIS HEP is a project that develops software for high energy physics HEP community. And yeah, so I could take any questions in that area.
Fantastic. Well, thank you so much for joining us today, Jim. It is a pleasure to have you as one of our panelists. Next up, I would love to introduce our guest panelist who has joined us today. That is Leah Wasser. Leah, I see here that you are the executive director of something called pyOpenSci. Can you tell us just a little bit about maybe your path and how you got to pyOpenSci, and what types of questions would you like to answer for us today?
Sure, Cameron. I'm really excited to be here today, y'all, so thank you for inviting me. So I have a background in remote sensing ecology, which Cameron already mentioned, and I have a really strong education past. So I've been working in data science, data-driven science education for about 20 years. And I'll tell you a little bit more about me in my talk. But I would love questions about anything related to code and peer review, and then pure Python packaging questions as well.
And Leah, this is one thing that I really love that pyOpenSci does, is a true peer review of code. Because oftentimes, right, when I submit a PR, it's just kind of a quick review, or maybe it's something thorough, but we're not going for any scientific publication or submission. And it seems that you all help very thoroughly with that process. So thank you so much for taking the time to join us today. We really would love having you. With that all being said, I would love to move on to our coding activity. We have prepared a very fun coding activity called The World Doesn't Need Another. And in this activity, we are going to focus on a number of Python packages that have simply kind of retooled the same thing or occupy the same space. Now, instead of identifying specific tools, we will be going through domains of tools and asking, do we really need a new one of these or not? And so let's go ahead and dive right in. Now, there have been many NumPy or Pandas replacements throughout the last decade or so, and I'm curious for our panelists, do we really need a NumPy or Pandas replacement? Do we need something like tensors? How necessary are they? I think we'll find that they might be, but I would love to open up to the floor. And of course, if you're in the audience, feel free to chime in. We would love to hear your thoughts in the chat.
You know, Cameron, I once spoke to Travis Oliphant, who brought together NumArray and Numeric to create NumPy. And he told me, in his honest assessment, NumPy wasn't really done. And then he proceeded to create at least 2 or 3 projects to try and supersede NumPy, none of which seemed to really catch on. So I suspect NumPy is in this weird space in the middle where it's not quite done. There are still some rough edges, but it is very, very hard to displace.
James, would the NumPy replacement happen to have more than 3 methods on the ND array for convenience?
One thing that I'm sure Tom will share with us is when we complain about the legacy nature of APIs like NumPy and Matplotlib, we shouldn't forget how old these tools are. They predate many major parts that make modern Python as modern as it is.
Absolutely. Anyone else from our panel? Do we really need a NumPy or Pandas replacement?
I'm going to stake out a controversial point and say yes, in that NumPy and Pandas are very much single core shared memory dense models of either dense rectangular or strictly tabular data, and not all data sets can fit into that, and that structure is not amenable to all compute architectures such as GPUs or various cluster methods, or in the case of or ragged data, and so that there is still space to build new and useful tools on something that seems as fundamental as the array or the table.
Tom, I heard recently about this amazing new tool for ragged arrays called Awkward Array, but I'm really eager to maybe see if I can learn more about that.
I guess I could speak to that because I'm the project manager for Awkward Array. Actually, for that one, yeah. So I was going to argue for the numeric NumArray split was really hurting the community, having these multiple options. So what happened in recent times, I think what probably motivated this question was that all the machine learning frameworks, invented their own array-like objects, and they were largely motivated that they wanted it to work on GPUs or have this parity between CPUs and GPUs. And just saying, I want an array to do all the array things, but I want it to run on a GPU, that's similar enough that it's the sort of thing that, it ought to be it seems like it ought to be in the same library. Like backend should just be an option. Having NumPy and CuPy, that also works. It's shared by 2 libraries. I think probably what happened is that the machine learning, developed, the deep learning developed too quickly for a standard to have emerged there. So we have to walk back and consolidate. And there's the it's not even open. It's a Array API consortium that's trying to pull these together, not into a single library, but into at least a single API, which is itself a huge benefit. Now, the original question was about ragged arrays. Well, actually, I think that ragged arrays sit enough outside of this because they're so different. It's not like flipping a switch and going from CPU to GPU, or flipping a switch and adding units like Pint does, or flipping a switch. There have been a lot of really interesting array alternatives that are like, you'd like them to be dimensions of the same thing. Ragged arrays are, not everything is going to be possible. You know, it's different enough that being a little bit secluded is, I think, a good idea. But still, we're trying to, reproduce the NumPy API as much as is conceptually possible.
I can add one more thing. I think another big difference between a lot of the newer frameworks and NumPy and Pandas is that NumPy and Pandas are very much a prompt execution. You call the method and it does it right then. Whereas some of the newer ones, what you're really building is an execution graph that then some other engine runs under the hood. And those models are very hard to coexist in the same literal code base.
That's another one, right?
Mm-hmm.
Right, delayed.
Yeah, we've seen that transition, right? Pandas with polars coming out now. They have the streaming API. They built exactly as Tom described, building an execution graph and then actually pruning, right, things to optimize that execution graph, and then actually carrying out the work that needs to be done, performing smart caching and things like that. And I think it's very interesting, this whole transition that we've had from the eager computation, right, things like NumPy and Pandas, to the distributed version of both of those, with where we actually build execution graphs and we can perform, right, simplifications, right, in the form of Dask. And now we're coming back in, Dask being built on top of NumPy and Pandas, those eager execution models. And now we're saying, okay, we've laid kind of the groundwork and the framework. Let's come back and let's spruce up the full back end of this, and then try and transition to something that will work better for us in the future. But in the large part, NumPy and Pandas, they're probably not going anywhere within, my guess would be the next even 5 to 10 years. I think they'll still be around. They'll still be pretty sturdy and supported, just because there's so much framework that's built around them already. But the Array Consortium, there's a very similar thing trying to happen right now with data frames, right? What is a data frame API, and trying to build a standard around that. And so there's really interesting attempts that we have all of these different tools and different tools. Let's try and make something and bring the community back together that maybe have splintered a little bit too much. But any final questions or comments, remarks on NumPy or Pandas replacements? All right, if not, let's go ahead and jump into round 2. Now, a lot of people throughout the last 10 years have said, I'm unsatisfied with Python's package management, so I made a new one, and it's better because I made it. And so I would love to hear everyone's thoughts on, does Python really need another package manager, or does there already exist a tool that can service most of our needs, and we can kind of code around some of the inflexibility it might require?
I'm happy to jump in here.
Yeah.
So this is a really funny space, because not only do we have different ways of like managing environments and managing installs, but like some of the tools, like if you're thinking about PDM and Poetry and some of those other tools, like they're actually full software development like workflow tools that happen to have environment and package management within that tool. And so I think that that's where sometimes comparing some of these tools becomes really difficult, because actually a lot of the time it was people trying to solve like an end-to-end workflow problem. And so then we got this other tool that happens to do package management. So I think that that's some of what's happening. And then the other thing is, as all of the requirements have been changing and getting updated, there's like some tools that can keep up with that and some tools that can't, that I think kind of relates to some of the Pandas and NumPy discussion that you were talking about, where if that becomes difficult, you like update a tool and you might want to not disappoint all your existing users if you're updating it to a point where that some functionality is lost. So I think that that's like part of what's triggering this happening in the ecosystem. But I wish that there was not the like, oh, I'm just going to create a better one on my own. And I wish there was a little bit more community collaboration around some of that development, because at the end of the day, I don't love this only because for users, it's really, really confusing to figure out where to start.
Yeah, and I think that's a great point, because Python has a very interesting kind of role in the broader programming language space in that Python has attracted a lot of people who wouldn't consider themselves programmers, but who need to use a programming language to get things done. And so these tools that represent end-to-end workflows are very convenient to use, but they also take away some flexibility. And so it's great to get started, with a tool that has an end-to-end workflow already defined for you. But there are some other people who consider themselves programmers who say, oh, why are you making all these decisions for me? I want to be in charge of the decisions. And so we have kind of this really delicate balance of tools that exist on either side of the spectrum. So I really appreciate those points that you brought up. Anyone else for, do we really need another Python package manager?
So I think one of the sources of pain in the Python packaging world is that we've addressed it as a Python packaging problem. Once you start doing anything with NumPy, SciPy, Matplotlib, Pandas, H5Py, anything where you're doing something high performance, you need access to native libraries, and part of the installation is a compilation process. And once you start distributing binary artifacts, you now need to make sure that at an ABI level, those artifacts can talk to each other. And so really the problem we need to solve is not a Python packaging problem, but a general packaging problem, because you can't really talk about distributing NumPy and scikit-learn together unless you also talk about distributing OpenBlast they both depend on. Or you can't talk about distributing like H5Py and PyTables without talking about the fact that both of them depend on libHDF5. And if you're not responsible for packaging things that have shared underlying libraries, you can elide a lot of this pain. But I think fundamentally it needs to be not Python packaging, it's just packaging.
Absolutely, because I totally agree with you. And that's because we've seen such, Python being a glue language for everything, just as you described, is we're trying to have, compiled libraries in other languages that are called by Python. And then you come to the question, well, these just get bundled in, right? If so, when they get bundled in, where are they compiled? On what hardware are they compiled? What flags am I choosing when I compile them? Is this going to work well for everyone's hardware or just, a subset? And I see you shaking your head. No, it's not going to work the best for everyone's hardware, but it also is way too much to ask, every end user to say, oh, download these and then you'll just run the compiler yourself. It's really easy. You just need like 8 different things. And if you're on a Windows machine, sorry, this is only for Mac or Linux. But I totally agree, Tom. It's a packaging problem, not just Python. Any other comments on another Python package management system? All right, with that being said, let's jump into our final round. This is a fun one. Does the world need another simplified wrapper on top of Matplotlib? Now, if you're coming from R, you might think that Plot9 is the greatest thing to have hit the Python ecosystem since Matplotlib, since it's a direct port or almost direct port of ggplot. But there are other abstractions built on top of Matplotlib, and even some abstractions that provide nothing abstract at all. They simply just simplify some of the user interface, some of the functions and methods that are exposed, which does come at a cost of flexibility. So I would love to ask our panel, does the world need another simplified wrapper on top of Matplotlib? Or should we start just telling people well, it's a big API, you can figure it out?
I have a thought on this one. I think there should be lots of Matplotlib wrappers in the world, but they should be clear about how they're specializing. And this is true of the non-Matplotlib, like the web, Vega space as well, or D3 space. If you're making it simple, what are you focusing on and what are you leaving out? Because I'm suspicious that it's not possible to make something fundamentally much simpler than those general purpose plotting libraries, be they Matplotlib or something else. But I do think that a plotting library for astrophysics, a plotting library for solar science, a plotting library for this specific kind of data set I'm working on is a really useful thing to have and can be a good entry point for people who have a problem in a certain domain and then might start to learn the larger API as they need to do weirder or more general things or things outside that domain.
Absolutely. Any other thoughts on simplified wrapper on top of matplotlib? I will say I'm in agreement with Dan here. All right, I'll share my 2 cents and we'll see if anybody else has some thoughts. My 2 cents is this. I think we definitely could appreciate some of the domain-specific plotting libraries, but please, please don't bundle an entire plotting library into some other library just through a .plot method on your object. It works, but it's not flexible at all. You end up having probably 100 different arguments to a single method that all control very small things about the plot that are already exposed to you through matplotlib's API with really not even that much extra code. If I have a method that creates a plot, it takes an axis and creates a plot, I don't need an argument called legend equals true or false or x label equals true or false. I should be able to very well add those on my own. And in that regards, we're simplifying our API and we're still leaning on the very high flexibility that low-level tools offer us. But that's just my take on it. I'm curious, any other final thoughts for the final round of our game here?
That's a very eloquent critique of declarative APIs. But no, I do agree with Dan as well that there should be more specialized wrappers on top of matplotlib. In addition to the domain, what makes plotting feel nice is when the plotting functions understand the structure of your data and understand that obviously the column named y should be the one you plot on the y and the one labeled date should be the one on the x. In general, that's not something that matplotlib could ever bake that assumption in, but in your library, you could have a very thin layer that takes in, your data frame or your dictionary of data frames or whatever the structure that makes sense to describe all of your domain's data and do the right thing for that data. And you can make plotting feel very fluid with a relatively thin layer of code on your side.
Absolutely. Thank you so much for sharing your thoughts, Tom. That does take us to the end of our coding activity. This has been a lot of fun. I always love these coding activities because we always end up having such a great panel for host and guest panelists who have some very amazing thoughts to share on each of these topics. With that all being said, I would love to turn things over to our guest panelist, Leah, who will be sharing some remarks on pyOpenSci. So Leah, without any further ado, I'll turn things over to you.
Okay, thank you so much for having me here today. I'm going to talk to you a little bit about pyOpenSci. I'm Leah Wasser. I'm the Executive Director and Founder of pyOpenSci. And I welcome questions. I know there might be questions in the chat, but if someone wants to interrupt me because there's a question that's relevant, I'm happy to do it that way, or we can talk at the very end of my talk as well. A little bit about me. I have a background in remote sensing ecology, and then I've built 2 other programs before working on pyOpenSci. One was the NEON Data Skills Program, National Ecological Observatory Network, and that was mostly an R-focused program building data skills around using NEON data. And then at CU Boulder, I built the Earth Analytics Program, which was a very much Python-focused earth science, environmental science type of program, heavy data use and a lot of data science training. And then in 2018, I started to think about and work on pyOpenSci, and I'm going to talk about that next because we have funding, and I've since stood up pyOpenSci as an independent organization. So pyOpenSci is really about supporting the open source software that is driving open science. And open source software is really the foundation for open science. We can't have open workflows without tools that you can install anywhere. And it also democratizes access to people that can participate in data-driven science because they can freely access tools and don't need to worry about licenses. And all of this is really accelerating discovery, scientific discovery and research. So when you think about this idea of open, you think about anyone can participate, and there should be lots of people that are in this data science space doing great science with lots of open and free data. And you would also think, because open source is so fundamental to open science, that maintainers are supported, maintainers are valued in the academic space. Unfortunately, that's not always the case. We know that not everyone can actually participate in this space for lots of different reasons. In fact, in tech versus open source has even a stronger diversity issue and challenge than broader tech does when you look at some of the numbers. And then open source maintainers are also not always supported and valued, particularly in traditional academic environments. So what I want you to do today is think about a world where everyone can participate in open science, a world where open source maintainers are supported and valued, and a world where scientists have the tools that they need to do the science that matters to them and to their research. So that's the world, and that's the vision that pyOpenSci is working towards. We have, and we are implementing things to get to that vision or to move towards that vision, including inclusive peer review of scientific software, and I'll talk about that in just a moment. We're developing community-driven packaging resources and standards, and I'll talk about that as well, and those standards in turn will support our peer review process. And then finally, we're supporting communities across the ecosystem, both scientific domain communities that are focused on Python, and also we have partnerships with groups like the Journal of Open Source Software, and I'll also get to that, and trying to just support the community in this effort. All of our actions, all of our activities, all of our programs are really driven by this community that's diverse and inclusive. And so the outcomes of what we're working on include multiple things, but some of those pieces include catalog of vetted, usable, and maintained Python tools that scientists can use. That diverse community that's really the foundation for everything that we do. Maintainers getting credit and support for their work in the forms of citations, in the forms of just a place where they can go and ask questions and get help. And then supporting the community broadly so that we're thinking about packaging and we're thinking about standards across the entire scientific community rather than just all of us trying to solve some of these problems individually or in. So first, I'm going to talk to you a little bit about software and peer review, which has really been our core program since we started in 2018. Before we talk about specifically peer review, let's talk about software first. So I'm talking about when you write code, and a lot of you might write code for your daily jobs, and you're writing code and maybe a script to get something done. And then at some point, you might start to modularize that code and generalize that code, and then you realize, oh my gosh, other people in this community probably could use what I have just built as well. And so I want to turn it into something that maybe others can use. And so that's only going to be useful if you continue to maintain that code. If it turns into something that looks like or becomes a software tool, it needs to be maintained, it needs to be documented so other people know how to use it. There needs to be testing, and there's a whole bunch of things that you would want to add to it to make sure that other people have good experiences using your tool. So pyOpenSci is really about implementing a peer review process that vets packages to ensure that they have the pieces that are important for other people using these tools, the pieces that I just mentioned, and I'll talk about that a little bit more specifically in just a moment. So the way our peer review process works to look at some of these pieces is first someone will submit either a pre-submission or a submission to pyOpenSci. Pre-submissions are for folks that aren't quite sure they want to submit to us or want to ask some questions first before they move forward. And in those initial checks, the editor-in-chief will work with you to make sure that you have the core files and components that every Python package really should have. Things like documentation, things like it can be installed across operating systems as it makes sense, README files, contributing files, open licenses, those kinds of things. So these are checks that even if you're not going through peer review, they're good things to look at as a checklist if you are interested in taking that next step of transitioning your code into something that looks a little bit more like a software package. Once those editor and chief checks are done, the peer review process begins where there's 2 reviewers that are volunteers and an editor leading that process. And I know that in traditional academia, review can be a little bit of a scary thing where you might get some really not so constructive feedback from reviewers, but we see review as a supportive conversation. And the goal of review is really to improve the quality and usability of the package. Like, that's the end goal there. And so it's a conversation that happens between the maintainers and the reviewers to get that package up to a certain level. And then at some point in that process, it becomes an accepted package in our ecosystem. We think a lot about things like maintenance to make sure that that package is maintained over time, because imagine if a scientist is using your tool and all of a sudden the package has a bug and no one's there to fix that bug. We'll also help maintainers if they need to step down or if they need some additional maintenance support with maybe finding another maintainer to help them. We also provide visibility for whoever, for the tool to the broader community, but the maintainer at the end of the day still owns the tool. So we're just really a support system and a network for maintainers. Now, finally, and most importantly, we have a partnership with the Journal of Open Source Software. So what that means is that if you're accepted by us, then you can also be fast-tracked through JOS if you're in scope. And what JOS provides is that citation piece, that cross-ref enabled DOI, Digital Object Identifier. And that's the thing that will add some value to your package in terms of it being also reviewed based on a paper that you write for JOS. So this is really a win-win where you can be accepted by us and accepted into the JOS ecosystem as well. This is an example of what a review looks like. All of our review is fully open, so you can see all of the conversation that happens. This is the top of a review. It's a GitHub issue, and you can see the editor and the reviewers and some other metadata around the review. And this is our editorial team. We have people from lots of different science domains from across the world that are working on this team. We're actually looking for a new reviewer right now. I'm going to be posting soon. So if that's something that is of interest to anyone, keep an eye out on our social media accounts, which I'll provide at the end here. Diversity is core to absolutely everything that we do. And so in all of the processes, we recruit people, we support people to make sure that we have reviewer teams with reviewer teams composed of people from different backgrounds. That's really important, and it enriches the review process itself. For those that are newer to review or maybe a little bit uncertain about doing review, but they have the technical science backgrounds needed to review the package, we offer mentorship. So that also allows other people that might not normally contribute to an organization such as ours to contribute, because we provide that support system. And then this is just an example of a review. Don't worry about all of the language in this conversation, but this is a conversation between our editor-in-chief and one of our maintainers. And the important thing here is that through this early conversation, this was before the package actually went into full review, we were able to help the author move their metadata into a more modern PyProject TOML file format. We were able to help them upgrade their documentation infrastructure, and we also were able to help them with some installation issues that they were having across ecosystems, because we have Conda Forge folks and they were struggling with some of the Conda side of things. And so that was really valuable, and this happened before the review even actually started. We were able to help this maintainer. Now, another thing that we've been exploring is partnerships with domain-specific communities. So right now, we're partnered with Pangeo, we're talking to AstroPy and PyHeliophysics and a whole bunch of other communities, because a lot of these communities are trying to address the same issue of there are so many ways to create a Python package, there are so many different tools. We want to develop some standards for what a package should look like, and we want to do some sort of review. But now you've got all these communities across the ecosystem developing their own standards and their own approaches to packaging. And wouldn't it be better if there was one organization that was curating that everyone could contribute to, and then we support that peer review process? And so that's what we've been working on. And it's really a triple win, because now with our partner packages like AstroPy or Pangeo, you can submit to us, you can get accepted by JOS, Journal of Open Source Software, and you can become a community-affiliated package associated with that domain, so AstroPi or Pangeo. And so this is really a valuable piece for people because it's one review process that supports multiple use cases and then uniform standards across the entire scientific Python domain. This is just an example of our website, so you can see that we have a bunch of packages already, and we're really quickly growing, so we have a lot of packages that are in review. In fact, one got accepted by JOS just today, and so this page will be growing over time. Now, I also want to talk very briefly about our community-driven packaging standards because this is also really important to our process. We're trying to address these questions like what packaging tool should I use? How do I create a Python package? And very specifically focused more on pure Python right now. Every page in our packaging guide is reviewed thoroughly by the community. So we have Conda maintainers, Conda Forge maintainers, members of the Python Packaging Authority, even people that are developing the tools like PDM and Hatch. All of those people review our content to make sure that we can get to some agreement on this is what we recommend for how a package should look like or what a package should look like and what tools people should use. It doesn't have to be required, but most scientists want some answers about like how do we move forward with creating a Python package. So while the development of our guide is a little bit slower because we have a very thorough review process that often consists of multiple pull requests and lots of feedback, at the end product is really a community-driven resource that we're curating in our ecosystem and using for our peer review process. This is just an example of a table in our package. I know Cameron had mentioned PDM, where we're starting to compare the features that each of these tools have to help users better understand what tool might be best for their use case. And then finally, I'll spend about a minute here and then I'll wrap up and we can talk if people have questions. I wanted to just mention that you might be thinking about like, what are the types of things that make a community inclusive? Because that's a word that we use a lot. And I talked about the peer review process, but there's actually more than just peer review to think about. And a few of those things include facilitating conversations where people can feel safe talking about things like issues of racism in tech or issues that they're having in whatever part of their professional environment they're working in. It's a space where people can participate and also feel supported. And one of the most important things that we've had to do to make sure everyone can actually participate, particularly in the packaging space, is a lot of moderation and a lot of enforcement of our code of conduct. So these are things that we really value, but we also take seriously and spend a lot of energy to make sure that people really feel safe and supported and excited to be in our community. So with that, I want to wrap up. If you're interested in getting involved with us, maybe as a reviewer or in some other way, you can check out our Get Involved page on the website. And you can also see here our social media accounts in case any of you want to follow us. I just want to thank, before I sign off here, the Sloan Foundation that has funded us. It's been amazing to have funding, and we've actually been able to grow so much in the past couple of months, thanks to that funding that Sloan gave us, and then Community Initiatives, who's our fiscal sponsor. So with that, I'm going to stop sharing my screen, and then if anyone has questions, I'm happy to answer them.
Fantastic. Thank you so much, Leah. I'm looking very much forward to hearing what questions we might have from the audience or from our host panelists. And in the absence of some audience questions, it does take a little bit for those questions to roll in. I would love to open things up to our host panelists to see if you have any questions for Leah or any points of discussion.
I really like the idea of providing support for review on the path to affiliated packages. At the synchrotrons, we had a conversation between Brookhaven and Slack in California about the idea of imitating AstroPi with like a scikit beam, which actually does exist but hasn't gotten a lot of resource. and we went as far as like copying over their affiliated package process. And I think we can say we concluded it's a lot of effort to even define that, even if you're not above shamelessly copying from another community. So I'm really glad to know that that's within scope for pyOpenSci, and I think it's something a lot of us could use.
Yeah, absolutely, Dan. And Palian and I at the developer summit that we were both at, but we were sitting working on this document. So what I'm trying to do is document all of it for other communities, just so it becomes a resource as well, because AstroPy had kind of that exact thing. They came to the conclusion that this is a lot of work to maintain. And so now we can work collaboratively, which I think is great. So yeah, that's great to hear.
Leah, we had a question from the audience, and we were curious. Can you give some indication of a threshold or maybe a litmus test, quote unquote, for submitting a package through the pyOpenSci review if it's going to be worthwhile for everyone involved?
Oh, I guess I need a little bit of clarification in terms of worthwhile, or like, what that question is getting at. Is it like, is that the question of, is it worth my time as a maintainer, or I just don't fully understand the question.
I think me as a research scientist, if I can, publish in JOS kind of quickly and nonchalantly, what do I gain from going through, I guess, a more stringent and thorough code review or review process?
Okay, thank you. Absolutely. So, JOS is obviously a wonderful organization. We're partnered with them. The main reason that we kind of started working in this space is the maintenance, and the fact that if you look across the ecosystem of Python packages, there's a lot of redundancy of packages that do the same thing and various states of maintenance and various states of quality, various states of documentation and usability. Like, I could go on and on about that. And so JOS, that is not their focus. Their focus is really reviewing code and providing that citable entity to take the place of that journal publication that an academic might get from peer review, that unfortunately maintainers just don't get that credit in traditional academic environments. So they're a publisher, whereas we're really thinking about the entire ecosystem, Python specific. We're thinking about redundancy of tools. So when someone submits, we're looking at that. We're also thinking about long-term maintenance and following up. We're thinking about tracking package metrics. So if you're a maintainer that's working on a tool, and one other thing, we also are thinking about supporting the maintainer as you're working on the package after the review if you have questions and need support. So if you're someone that's interested in maintaining your tool over time, rather than getting that publication and being done with it, which some people, that's what they want, and they move on to the next thing, and that's fine. But if you're interested in that longer term maintenance, having people use your tools, building community around the tools, visibility, support in that long-term maintenance, we're a community that you can come to and stay and stick around and get help and talk to other maintainers, and also think about if you need to step down maintaining in 5 years or 4 years or whatever, we can help you with that transition as well. So that would be really the reason why you might think about us versus JOS. And it's not a one or the other, but it's just, we're not an endpoint publication. We're really a community that cares about software as it's developed and as it evolves and the ecosystem over time.
Great, thank you so much for that, Leah. There was also a follow-up. In addition to being worthwhile for me as somebody who's submitting code, how would we know if it's worthwhile for me maybe as a reviewer? For example, some indication of estimating, right, the potential audience that a given piece of code or piece of software might reach?
Yeah, that's a great question. And in fact, I don't have a good, perfect answer to that. For example, we have a package actually right now that we grappled with. Its scope is so narrow, we're thinking, what would the broad application be? Like, how many users will this package get? But we do not right now judge a package on that at all. We decide if the package has a valid scientific application that we think some people might find useful. And if the author wants to continue to maintain the package, and by the way, the editor-in-chief in our community, we make that decision, so the reviewer doesn't have to make the decision. If you're reviewing, we've already decided that it's worth the time. But that scientific application is important. And you know what? Some tools are going to come through our process, and they're not going to ever become huge. And then we have some tools that are already in our ecosystem that have a fairly big user base and are being used, and that's okay.
Fantastic. Another audience question that we had is, well, it seems like there's a lot of kind of overlap between a pyOpenSci review, maybe a JOS review. Is there any benefits to going through a pyOpenSci review? Does it help with the JOS review?
Oh, well, so if you go through the pyOpenSci review and want to get accepted by JOS, there's not a second review. So you don't have to worry about that piece. And really, they're just looking at your paper. They're not going to look at the code again. The benefits and the difference between our review and theirs is we're spending a lot of time thinking about best practices for Python packaging. We're spending a lot of time thinking about usability and documentation quality and making sure that tools have beginner-friendly documentation. In the future, the plan is that we're not only going to be thinking about it, but we hope to have someone that can actually help maintainers like up their game in terms of the usability of their package in the form of documentation and tutorials. Like that's something that we hope to do in the future. And so all of those things that were very Python specific, we're thinking about modern standards. With JOS, it's going to be a quality review, but it's not going to be as specific as ours, and they're not going to be as targeted as ours. So that's really the big difference in terms of the review itself. But again, you don't need to choose. If you wanted to, you could come to us and then still get that JOS acceptance, but now you're a part of our community and you have a support system around you.
Yeah, and I think that's the most important aspect of why, or one of the most important reasons why you partnered with JOS in the first place, was to really help make people's lives easier, not make them do twice as much work. I know that's a very common pushback for open science in general, is we're asking more of the researchers to do more to make things more accessible, when I think it should be at an organizational level that these conveniences are introduced to really promote open science. Not ask the researcher to do more work, but to help them do more work.
Exactly. And I love that framing, because like we even have a package that's going through review right now where the maintainer is getting some help from the reviewers in terms of some of her like CI infrastructure, and I'm watching her open pull requests and she's like inviting the reviewers to her repository. And so I think that idea of review as being this hard thing that people go through and critical, we want to flip that. And we really want this to be about, we truly want to support maintainers and help them, not like give you more work to do. And so right now we don't have a lot of, if reviewers will volunteer to help, that's great. We encourage that. In the future, I want to formalize that. So we're really helping with like hands-on, let's help you get this package up to where you need to be. Not need to be, but where it would be more useful to the community or easy to use. And how can we help you do that? It's not a critical review.
Mm-hmm.
I think it might be worth just hopping on that, thinking about how the incentives are different with academic review. Reviewers might be incentivized to be pretty tough, but the point of getting code open is that we can share it and use it together. So it's less of a barrier and more of a helpful community, right? I think it's a very different vibe than the way we use review in an academic publication context.
I agree.
Yeah. Everything comes back as revise and resubmit, except here are the revisions you need to make.
Reviewer number 2.
Well, Dan, in that spirit, a excellent question just came into the Q&A from our audience. And I would love to open this not just to Leah, but to all of our panelists, because I think it's so interesting. How close are we as a community to a society where prolific software authors and maintainers are able to have a successful career in academia in the absence of a track record of a traditional quote unquote, right, publication.
I can think of existence proofs. I don't know if it's right to throw names on here, but there are people who have done it in the current generation, and I think the path, one or two academic generations back would have been much harder. But it feels that there's still, like any academic career, a degree of luck involved, and there's plenty of room to make that more recognized and more mainstream. What do you think, Leah?
Yeah, I mean, so I the academic system moves so slowly. I think that I've seen some change in what's valued traditionally in that like moving away from those traditional values. But I think that right now what it comes down to as a researcher is there are some labs that do really value open source and are contributing to open source and are contributing to non-traditional pathways, like maybe not traditional papers, maybe blog posts. And I know some of those faculty. One of them is actually on our editorial board, Titus, and he's been with his lab, he does things differently. But I think the challenge is that he's also tenured faculty. And so, I think it's harder if you're early career to start off and try to push those limits. So I don't know what others think, but I see examples of people, Ryan Abernathy and other people that have been in labs where they're doing things differently, and it's awesome. And they're supporting open source, and they're not following traditional paths. But the question is, could everyone do that and kind of be successful? I don't know. So it's a tricky space, I think, right now.
Yeah, I would definitely agree. Not in the current setting or current environments, everyone couldn't do that. But I do see, right, more and more type of academic, like research software engineer type of positions than there were, say, a decade ago. And as a result, I'm not seeing a ton. I'm probably not as close-knit as you are with a lot of them, but I don't see a ton of, say, university-like PIs for who do software kind of as their main thing or do programming as their main thing. And in discussion for could a younger PI come in with this software track record, I think it might be possible. It would definitely be hard because, right, having tenure track really gives you the flexibility, or having tenure, I should say, sorry. But I think what's a big ask as well is I've met and trained a lot of grad students, was a grad student myself, and all of my peers when we first started grad school, we were faced with one task, and that was, okay, by the end of this 5 years, if you're still around, you need to be, right, a leading expert in whatever small field that you have chosen. But then number 2, year 1, they're like, wait a minute, I need to learn programming? What is this? And so nobody really associates, right, typical academic research with kind of the heavy use of programming for a lot of different tasks in a lot of different fields. And so you end up as a graduate student having to decide, where are you going to spend your time? Am I going to be able to do computations and do kind of the mechanical work very quickly? Or am I going to be the person that reads, right, the majority of the literature that's out there and coming up and asking really big and interesting questions, but maybe not necessarily knowing how to analyze the data collected based on those questions or carry out those actual investigations? And so we really need, I don't want to say we need more individuals, but we need more communities like this, where if you are a very bright PI, but your coding chops aren't, the highest in the world, you can rely on communities like pyOpenSci or having some type of support for software and programming. And so I think that's the closest direction that we're at right now. I don't see many labs, like the majority of labs, being overrun or overtaken by pure kind of programming. I produce software that supports academics, but I could be wrong.
I would say a positive step in this direction is that the Simons Foundation has a call out now specifically to fund junior tenure track faculty who have made significant contributions to software. Put it in the chat. It's specifically aimed at mathematicians and theorists. Um, uh, so you know, in the physical sciences, so it's not completely general, but this is the fact that there is at least one funding organization putting some money behind this, I think, is a positive step. But that said, in the words of, I think it was Wes McKinney, the scientific Python ecosystem is built on the ashes of academic dreams. And to some degree, that's still true.
That reminds me, Tom, I saw something very funny, and it was I spent 5 years getting my PhD, and what do I do now? Well, I just kind of click around Excel sheets, and I'm a data scientist. And so we have like this kind of general notion that programming and academics don't overlap a lot, but I actually am very hopeful for the future because right now we are seeing people kind of take on that track. And in what you just said, in my opinion, the best thing we can do for academics to encourage them to do one thing or another is not to tell them or express to them the importance of things like open science, but to give them money and incentivize it. Because I can tell you about how it's for the betterment of all mankind, but at the end of the day, you need to make money and we need to provide incentivization in that form to really start making change. Any other questions from our panelists or any other follow-up on that topic? If not, I do have one final question for you, Leah. Leah, as someone who writes code fairly often, how could I get involved as pyOpenSci? And I have a follow-up. Leah, as someone who doesn't write code very often, is there still a way I can get involved in pyOpenSci?
Oh, those are great questions. So if you're someone that writes code and is excited about code, you can always sign up to be a reviewer. Or if you have questions that are kind of in that packaging, like moving your code into something that looks a little bit more like software, we have a discourse page where anyone can come and ask questions, so you're welcome to do that. If you're someone that doesn't write code, but you're interested in what we're doing, we have a bunch of resources online and that will be growing, and we've had people that have come in and just even found like typos in our guidebooks or have had just general questions related to our processes. So if you're comfortable with GitHub, not even submitting a pull request, but like just typing in text in an issue on GitHub, that's a way that you can engage with us. And we've had lots of people that have been first-time contributors because they just looked at one of our online documents or our website and said, hey, I found a typo, or hey, have you ever thought about this? It would make it much easier for me to get involved, and just left some feedback. So those are some ways that you could engage with us. And we're also on social media, so that's another way that you could just kind of follow what we're doing if that's of interest to you as well.
Fantastic. Thank you so much, Lee. And I do have to say, if you are feeling hesitant to make a contribution to pyOpenSci, they are a wonderful group of people. They're very supportive. It's not like, maybe your experience you had on Stack Overflow where you posted a question and then you got a bunch of answers telling you shouldn't have even asked that question in the first place. pyOpenSci really is a supportive community. But on that note, I do have to say that this has been a fantastic exchange, and I would like to extend a huge thank you to Leah from pyOpenSci, and a thank you to all of our audience for joining us this month. If you're not already signed up for our newsletter, make sure you subscribe. The subscription link can be found on our website, and that's meetup.doepy.org. Or if you don't like receiving 1 or 2 emails per month, well, make sure you just keep a regular eye on that website for information about our upcoming exchange in July. Thank you all again for joining, and I'm looking very much forward to seeing you again next time.